tomorrow will be better. Solve by substitution this pair of simultaneous equations. Follow me, dear friends. Solution. Like I said in the previous videos, each time you have a mathematical problem to solve, don't jump into it hastily. Take your time, examine the data, exploit every small opportunity you have. For instance, in this question, we can notice clearly that in the first equation, the coefficient of x here is just 1. And here we have 3. Now, let me start by explaining what substitution method is all about. Unlike elimination, the substitution method consists of making one of the variables in any one of the equations the formula first, and then using this variable, which is the subject of the formula, and substituting it in the equation which you haven't used. Okay, and that's the name substitution method. When you do this, you will now have an equation which has only one variable, which is easy to solve. And when you solve for that one variable, you can now come back to the equation which you had derived from the start and then find the other variable. This is how easy it is. Okay, so follow me here, dear friends. Let's do it systematically. Now, I will name them as so equation 1 and equation 2. And I will say from equation 1, find x. So I'm going to make the variable x the formula in equation 1, okay, as follows. Start by rewriting equation 1. X plus 2y equals 14. Now, to make x the subject in this formula, all you have to do is to send 2y to the right, okay? So this implies that if you want to find x, I repeat, carry 2y to the right, and when it moves, it becomes negative 2y. Very good. So this means x will be equals to, there was 14 already to the other side, and then now minus 2y. And this is what I was talking about. This is a new equation we just created, and we can call it equation 3, okay? So what do? What we have just done right now is we have made x one of the variables, the subject of the formula of one of the equations, which is equation 1. Now, what do we do next? We will use this equation 3, which has x, and substitute it in the unused, okay? I repeat, in the unused equation. All right, don't put it here, it's going to be erroneous. Put it in the unused equation. So I will make the statement here and I will say put the value of x in equation 2. All right, in equation 2. It's very important to make such statements because it reduces the risk of errors. All right, so after having said this, I will start by rewriting equation 2. All right, so I will say equation 2 again is 3x plus 4y equals 34. All right, but I'll make a very important statement here and say, but we already found x, but x already is equal to 14 minus 2y. All right, so this signifies that everywhere in equation 2 where I will see x, I won't write x anymore, but I will write all of this, okay? So this implies that instead of again writing 3x, I will write 3 into 14 minus 2y. So this is where this method derives its name from, substitution, because right now we are substituting x by its value which we found here. All right, it's all about substituting, replacing. Okay, so here the equation says 3x, so 3 all of this now plus 4y, okay, equals 34. Now notice that in this other equation, or in this equation 2, which we have substituted x by its value, we have only one variable this time around. We have only y, okay? So, and it's pretty easier to solve it this way because you're left with just one variable. So I will do a very small expansion here because when we have this, it means 3 has to multiply everything which is in the parentheses, in the bracket. So if I simplify this, so later I'm going to say, this means I have 3 times 14, which is 42. Okay, now 3 times negative 2y, which is negative 6y, will be equal to, oh no, not yet equal to, so plus 4y, okay, be careful with mistakes, plus 4y equals to 34. All right now 34. So all I have to do right now is to simplify this equation by sending this 42 to the right side, okay? Now, on the left side, what will I have left? I have negative 16y plus 4y equals, here I'm going to have 34, and then when 42 moves, it becomes negative 42, okay? Simplifying this further is going to be, this is negative 6 plus 4y. Be very careful with signs, okay? This is going to give you negative 2y because you have a big negative number and then a small positive number. The result is going to be negative, okay? And then here, a small number being subtracted by a big number. Again, it's going to be negative. 38 minus 42 will be negative 8. How do we find y at this point? Divide. Very good. Divide both sides by negative 2y. Sorry, negative 2, right? Be careful. So, divide both sides by negative 2. Not 2, negative 2, okay? Because negative 2 is what is binding y. And we want to free y from whatever is binding it, which is called a coefficient. So, we divide it not just by 2, but by negative 2, right? So, negative gives us plus here, 2, 1, here, 2, 4. Therefore, y equals 4. And there we go, we have found y, one of the variables. We use this variable again and substitute it in equation 3. It's all about substitution, guys. This is a substitution method. So we will substitute the y in this equation by its value. So again, I will make the statement, put y in equation 3. Put y in equation 3. Again, I start by writing equation 3, which is x equals 14. Just to remind you that it's important, guys, to present your work the way I'm doing, to make necessary statements like this, because if you do this, whoever is reading you knows that you know what you're doing and they can easily understand, and it helps you by reducing the risk of making errors, okay? So after you've said this, you will make the statement again and say, but we already found y, but y equals 4, okay? So this implies, let's now do again, substitute y by its value 4 in this equation. So I'll have x equals 14 minus 2, no more y, but this time around 4, okay? It's all about substitution method. So here we just have to simplify. We already have y alone on one side, which is equals 14 minus 8, okay? And therefore, here this gives us 6. Therefore, x is nothing else but 6, guys. You can always verify your answer by substituting x and y in either one of these equations, because tomorrow will be better.